So before we identify our rigid body, okay, I'm reminded that we have to draw our transformation. So this is X, Y, rotation about Z. Just to remind you, in Cartesian, this is I, J, and this is our K component. Okay. So we have to identify our rigid bodies. So we have our member BE as one of our rigid body. Another rigid body is our member A, B, C. And the other rigid body is AD. Okay. The tricky part is A, B, C. That is the tricky part. Okay. So knowing that member ABC is a rigid body, we can also specify that omega AB is also equal to omega what? BC. Okay, because they are a rigid body. Okay. So the first thing to do, let's do something simple first. Okay. Or before we do something simple, what are we going to assume? Okay. Right? We are going, what are we going to assume? So let's analyze this on how omega will affect the entire structure. So if we focus on the omega, omega is going to rotate in what? In a anti-clockwise direction. Okay. So let's make a guess. Is C going diagonally upwards or diagonally downwards? Come on, anyone? Downwards? Okay. So we are going to assume this will be moving what? Downwards. Okay. So this is our VC. Right. So knowing that that is our VC, we know that we have two components over here. Okay. So the two components will be equal to, and we are given that this is 45 degrees. Am I right? So when that's the case, we have minus 0.707 I and minus 0.707 J. Okay, so this is our VCI. This is our VCJ. Okay, because cos 45 is equal to what? 0.707. Okay, so we know that. Now D, you want to assume up or down? Up. Okay, we assume up. No problem. Customer is always right. And the angle is also 45 degrees. So this is our VD. Okay. So we know that this is our velocity vector. So we know that this is minus 0.707 I. And that is the one over here is 0.707 J. Okay, so this is VDJ. And this is our VDI. Okay. Yes, sir. Did I? You're right. Oh, no. It's not working now. Thank you. Where are you? A pint at the end of the term. I can't give you a pint now because you're too drunk to do 2P. Thank you so much. Okay. So let's start from C. Okay. Let's analyze. Okay. Okay. Let's analyze. Piston. Let's analyze piston C. Okay. So what we can find is we can determine what from here by looking at piston C, right? So ABC are a vector, a rigid body, right? So we can write that VC is equal to VB plus by omega BC cross R C from point B. Okay. So there are few things that we don't know. So with this, the unknowns are VB and omega BC. Okay. Then we have to again assume what is our omega BC direction. Okay. So omega BC direction, because we are just going to make this is just assumption. Okay. This is my assumption that this is our omega BC. And I'll write down here omega DC. For now, we just what? Assume. Okay, we just assume. Right? It can go the other direction also. I don't know. Okay, we just make an assumption. Okay. So unknown are VB and unknown are omega BC. Okay. So let's try to find out what is our VB. Okay. So if you look at our VB, right? If we were to now focus on VB, okay, so I'll write, we are going to determine for this case, VB is only going in how many direction? VB only has a I component. Okay, VBJ is equal to 0. And why is that? Remember, we were talking about this yesterday, right? So if I put the circle over here, right? And we are going to have point B exactly down here. Point B only has one component on the velocity vector. Okay. Now, if point B is at this position over here, right? Right? If it's at that position over here, then we have both components I and J. Are we clear? That is why it's so important to say that we are analyzing based on what this instant. At this moment, what is our VC and our what and our VB. Okay. Right. So we are going to determine our VB. So we note that VB only has a I component. So if we form the expression, right, VB, or we are going to analyze rigid body BE. Now, in the term test or exam, okay, you no need to write this. Okay, I write this because it's notes for you to tell you what we're analyzing. Are we clear? Okay, so we have VB is equal to VE plus by omega BE cross R B from point E. Okay. So we know that this is equal to minus VBI. VE is equal to 0 because point E is fixed. Okay. Then we have minus 30K cross. Now, point B, okay, relative. So this is your reference. So it is only in J is positive 0.05 what? J. Okay. So minus VBI is equal to 0 K cross J. So K cross J is negative. You got negative over here. So now this is going to be positive. So 30 multiplied by, so this is equal to 30 multiplied by, wait, K, wait, my mind is VBI negative, okay. K cross J, okay, K cross J is negative, right? Then this will be positive. K cross J, come on, Eugene. Too many things in my mind. Okay, so K cross J is I. So this is what? This is negative. So negative is positive, plus by 30 times by 0.05, 1.5. And this is in your I direction. Okay. So what we have now, right? What we have now is VB is equal to minus 1.5 meters per second. Now I'm scratching my head a bit. Did I put the direction wrong? Yes. Yeah, Eugene, anti-clockwise. Thank you. That's why I'm scratching my head. Why I'm scratching my head? Because the physics don't work out. Thank you. Okay. Where are you? 2 pints. Okay. So, sorry. So down here, if we look into, so we know that VBI